Hi, everyone. Namaste. Good morning, good afternoon, good evening, wherever you are. Thank you for making time to join me for this NewMR webinar. Today, I'd like to talk about something that makes a lot of people anxious, statistics. And specifically, I'd like to talk about significance testing, those teeny tiny p-values that decide whether we did a great job or a horrible job. So let's start with a quick little poll. If you dare, leave your answer to this question in the chat box. How would you feel if you never had to run any t-tests or chi-square tests again? Would you feel thrilled, happy, unsure, sad, or miserable? Now, if you follow my Twitter account, you know I love statistics, the simple ones, and especially the complicated ones. But despite that, I'd actually be happy if I never had to run a t-test or a chi-square to get p-values again. Maybe even thrilled. So why is that? Well, let's start unpacking that idea. And since I'm going to talk about p-values quite a lot, let's make sure we're all on the same page. So p-values represent the probability that the differences we see in a sample would be the same or as large as what we would see in the population. So here's an example. Let's say we got bored with the current package design for these Fruit Loops, and we wanted to test a new package with a much bigger version of the toucan bird on it. So we had the marketing team make this new design. We found an appropriate target group of people who eat this kind of cereal. We fielded a questionnaire and analyzed the data. And as a result of our research, we got a p-value of 0.11. The probability that the difference we see here is the same or larger than what we'd see in the total population is 0.11. Does that mean we should switch from the current package to the new package? Well, based on the rules we normally use with p-values, we'd have to say no. 0.11 isn't small enough. It's not trustworthy enough, so we should probably pass. But what if the p-value was 0.07? Does that change how we feel? Are we still nervous? Is this still an iffy decision? More importantly, think about why this is an iffy decision for you. Is 0.07 really any different from 0.11? One last try. What if the p-value was 0.05? Would you immediately decide that the new package design is better? Based on how we use statistics on a daily basis, a lot of us would probably say, yes, we should switch to the new package design. But is 05 really all that different than 07? Of course not. Why should we suddenly change our mind over 0.2? It doesn't make a lot of sense. What does this tell us about p-values? Well, it reminds us that p-values are arbitrary. We could have set our decision p-value at 0.1, or at 0.001, or at 0.736. It's really just a matter of personal preferences and industry norms. P-values are easy ways for us to identify when we want to pay attention to things. They speed up the process of determining when we should look at something more closely. But clearly, a p-value isn't enough. It still feels like important information is missing. Let's try something else. What if we did the research with a sample size of 25? Based on 25 people, we learned that the current package was preferred. Now, are you ready to say goodbye to the proposed package? I highly doubt it. What if we know the current package was preferred when 150 people were tested? Are you ready to switch packages now? Probably not. And what if we tested with 300 people? Most of us do a lot of our research with sample size. I feel a lot better with that sample size, and I'd be ready to move forward, except we still don't have enough information to feel good about telling a client to switch packages. Sample size give us comfort. We know we like larger sample sizes because we can be more certain that the results didn't occur just due to random chance. But just having the sample size, even if it's 1,000 or 5,000, is not enough. So let's try one last thing. This time, let's say we know that 51% of people prefer the new package. Will you make the switch now? That's what you've been craving for the last few minutes, right? But obviously, 1% doesn't mean anything. 1% is sampling error. It's questionnaire design error or data analysis error. So no, we're not switching anything. What if 55% of people prefer the new package? Are you ready to switch now? I'm sure some folks still quite aren't impressed yet. All right, what about 65%? Are you ready to switch packages now? So I know I am. I'd be doing a second confirmatory study with a brand new sample to make sure this was a real difference. And at the same time, I'd be grabbing everyone in design and marketing to get this new package switched over and then figure out how I can recycle all the existing packages. At the same time, I'd be wondering if the sample size was 17 people and 11 people preferred the new package. That is worrisome. So what we've seen is that effect sizes are exciting, far more than sample sizes alone, and somewhat more than p-values alone. But more importantly, we've seen that we need more than just the p-value, or the sample size, or the effect size to feel good about a decision. So let's try this one more time. Let's look at 3 scenarios that each use 2 pieces of information. As before, if you're brave, type your answer in the chat box. From these 3 scenarios, pick the one scenario that would convince you to tell the client that they should switch from the original package to a brand new package. So scenario 1 gives you a sample size of 300 and a p-value of 0.01. Scenario 2 gives you a sample size of 300 and an effect size of 35% versus 55%. And scenario 3 gives you a p-value of 0.01 and an effect size of 35% versus 55%. So type your preferred outcome in the chat box. Now, what scenario did I bet all of my gold coins on? I did not bet on scenario number 1. This makes me feel like I'm doing research with my hat pulled over my eyes. I can't tell what happened. I can't tell if there was consistent agreement or a few people with overwhelmingly strong preferences. I also didn't pick scenario number 3. There's definitely a case for scenario number 3. We love p-values of 0.01, but I still feel like I'm making decisions without having all the necessary facts. I bet on scenario 2, obviously. That's because the difference between 35% and 55% is really meaningful to me. That's an effect size that would make me strongly recommend to the client that they should do a confirmation study and switch packages as soon as possible. And I like the sample size. It's large enough that I know the variability among responses is probably due more to real differences between the package rather than random error in the sample or in my research processes. My point here is that we sort of don't need sample size and effect sizes and p-values to make a good decision. When we design studies, we need to make sure that we start with sample sizes that are large enough to generate statistical significance for the effect size we need. Running a t-test or a chi-square to get a p-value doesn't add anything to the story when you already know you picked a large sample size. And it doesn't matter if the p-value is 0.04 or 0.06, those really are no different than 0.05. What's obvious is that a lot of researchers have become overly dependent on p-values. It's almost like we turn off our brains when the data is on our hands. There's lots of reasons we do that, but I'll list out just 3 of them. First, we use p-values because the data is complicated and we don't understand it. I recognize that multivariate data like cluster analysis, regressions, turf analysis, those are complicated. That is not what I'm talking about here. We need to run formal statistics for those analyses. What we need to think about, though, is whether p-values help us understand the data. And the quick answer is no, they don't. P-values will never make sense of the data for you. All they can do is point out the likelihood of certain differences between numbers happening. Here's another huge reason. Many of us use tabulations that look like this. Teeny tiny numbers spread across thousands of rows, 100 columns, 100 pages, and it's so hard to read. Hunting for significant p-values is much faster if we just have to focus on those p-values. But doing this completely disregards a basic principle of significance testing. Some of those p-values are going to be significant just because of chance. Which ones? I don't know. You don't know. Nobody knows. What's the point of hunting out every single significant p-value when bunches of them are going to point to differences that won't be reflected in the population? It doesn't make sense to present every significant difference as interesting. And the third reason I'll point out is that we use p-values instead of planning ahead. If I had planned ahead, this sentence would have fit on the screen properly. What often happens is we don't plan for 2 or 3 specific hypotheses as part of our overall research design. We don't plan on how we would act on specific answers to specific questions. We just throw everything in the questionnaire and figure, I'll wait for the p-values to tell me what to look at. And you know what that's called? That's called random error. Obviously, I am not arguing against statistics. Most of us don't have the brain power to look at data from 1,000 people and identify segments of customers from 100 numerical and categorical variables. We will always be dependent on statistics for things like segmentation, conjoint, forecasting. What I am arguing against is the use of statistics and p-values in particular without thinking. P-values cannot tell you if a new concept is a winner. They are just another piece of information that can aid in our personal judgment. So how do we stop relying on p-values? How do we get to a point where we don't even use p-values when they're not necessary? First of all, we need to plan ahead. That means outlining all of the hypotheses ahead of time. You probably have maybe 5 key questions that you really need answers to. Which concept is better? Which segment is more desirable? Which purchase driver is most important? Lay out those questions ahead of time, along with your hypotheses about the answers. It might seem like this adds time to the process. If that's the case, you're probably just not ready to start the research yet. Second, take some time to really understand the category from end to end. We cannot treat every category the same. Just because you have extensive experience with food package tests doesn't mean you understand pharmaceutical package tests. Figuring out the most appropriate effect sizes, sample sizes, and yes, p-values is highly dependent on the category, as you'll see in a second. Third, figure out what you can and cannot action on. Why ask questions about something? Why run stat testing or significance testing on things that you cannot action on? If you're never going to price something below a certain amount or do a certain color or a certain size, then it doesn't make any sense to waste time running a t-test on it. Now, more importantly, know when you will action on something. Does it make sense to change the package design for a preference of 49% versus 51%? Likely not. What about if the difference is 45% versus 55%? Is the return on investment there? Will 5 people be happier with a new box? Yeah, that's probably not good enough to change a cereal box. Will you save the lives of 5 people? This very well could be sufficient to change the message on a vaccine package. Basically, you need to know the entirety of your category and when you can action on something. Lastly, choose your sample size and stick to it. Given your hypotheses, given your category, given the effect size you need to achieve to take action, you can then choose a sample size that is most appropriate for that question. Personally, I love a sample size of 500. If I think about a lot of research studies in packaged and consumer goods, it's common to see preference scores somewhere around 30%. Personally, I wouldn't take any action on a difference of 30% versus 35%. But I probably really would think about a difference of 30% versus 40%. So knowing that, I get out my trusty significance testing card to figure out that for 30% to be significantly different from 40%, I need a sample size of about 400. Of about 500. And once I've done that, I actually don't need to do any basic statistics anymore. No t-tests, no chi-squares. I've already designed my research so that anytime I see an effect size I would want to act on, I already know that it's statistically significant. And a bonus, I won't be disappointed when it's significant at 0.6 or 0.4, because those are really no different than 0.5. And by the way, this is the sample size card I got from B2B International just about 20 years ago. It's in rough shape because of how often I use it. All right, now after all that, here's the moral of the story. If you need a p-value to decide whether your data is worth looking at, it's not. You need to design a new research hypothesis, figure out what effect sizes are required to take action, figure out what sample size is required for those effect sizes to be significant, and then try again. Thank you, everyone, for making time to hear me out today. If you ever want to chat about p-values or research design, you can find me on Twitter or LinkedIn. So until then, I'm happy to take any questions you might have at this time. Namaste.